All right, let's get started. Hi everyone, my name's June. I make plugins for Unreal Engine. I'm here to talk to you today about DevOps for Unreal Engine. I do a huge number of Unreal Engine builds across multiple products, platforms, and configurations. Plus I need to run automation tests and gauntlet tests, and managing all of that as one person, I need to have a very good DevOps pipeline so I can actually sustain development. So if you are doing Unreal Engine development, what are you using to build today? You can use the Unreal build tool, automation tool, build, cook, run, that sort of thing from the command line. But these have problems. They're very complicated. If anyone could tell me what the full command line is to do a build for an Unreal Engine project off the top of their head, I would be very impressed. They build stuff in sequence. They don't do stuff in parallel. There's no tolerance for transient environment failures, and if the build failed, you have to start the whole thing again, and then how do you run automation tests and so on and so forth. So I thought I'd solve that. I wrote a tool called the Unreal Engine tool. It's very kind of on the nose. It is a single portable executable for Windows and Mac OS. It does everything that you need to do. It's 100% free and open source. If you would like to build your project, you type UET build at the command line and it builds your project. If you want to run your project's automation tests, you run UET tests and it will run all the tests that start with your project name. If you're doing plugin development and you want to build your plugin, it's pretty much the same. You just need to set the engine version since projects have an engine version associated with them and plugins don't. And again, running automation tests for plugins, it's the same UET test and then the engine version. Yes, it's that easy. UET build will also give you much nicer build output. So if you've ever built something in Visual Studio and you're like, I don't know how long this has got left because UBT isn't showing me any build progress, UET will tell you exactly where you are in the build with percentage, total, that sort of thing. Now if you know UBT, you might be wondering how does that work. UET actually pretends to be in Credibuild if you don't have it installed, and this lets UET take over the execution of the build process using the task file, and it allows it to show all of the the individual output and compute the overall progress. But it also means that we can, UET can retry all of those transient failures, like if your page file is temporarily out of memory, instead of build failing, UET will be like, I'll just rerun that for you, it's totally fine. There's plenty of options on UET build, so again, you plugin or you project in the current directory you're running in, but you can also use -P to point at any directory that has a plugin or project in it. You can build for shipping, you can turn on strict include where you use header checks. You can build for additional platforms on top of just the host platform, and there's more options which you can find through --help, and it's all rather self-documenting. When you're using UET test, it'll show you the progress of all your tests at the command line and tell you, how long it took to run them, and so on and so forth. It'll also run all of your tests in parallel, which means it's better than the session front end built into Unreal Engine. It'll start multiple headless Unreal Engine instances depending on the available CPU and memory on the current machine, and it'll run the tests in parallel across all of the workers. It can rerun individual tests without restarting workers, so it means if a test crashes a worker or if a single test fails, you don't have to restart the whole test run. It can rerun that individual test. The way it works is I re-implemented the farchive RPC protocol that Unreal Engine uses in C# so that UET can directly control Unreal Engine instances just like the session front end, and that's how it gets that more granular control than you get through just the command line. You can also generate Visual Studio and Xcode projects from the command line, UET generate. You want to do it for a different engine version, fairly straightforward. If you have a source-based version of the engine, you can actually use UET generate and give it the path to all of the projects on your computer that you want to include in that UE5 solution file. It'll do that as well. You can use UET config to quickly manage some global build settings. For example, if you want to turn on strict includes when you're building in Visual Studio, you don't have to go and remember what the build configuration XML is anymore. You can just type that, UET config, include what you use on. If you want to use all the CPU cores, regardless of how much memory you've got available and really, throttle your machine, you can just turn on max CPU and, you'll have all your cores used. So how when you install a new version of the engine and you try and build and it's like, hey, you don't have the right version of the SDK installed and you have to go hunt down in the Unreal Engine docs what version of Android Studio that you need today. You don't have to do that anymore. You can type UET install SDKs and then the engine version you have installed and it'll go and install all the SDKs for you. And it actually figures out all of the versions needed by looking at the Unreal Engine source code files where UBT specifies all the SDKs, and it'll hit, for example, for MSVC, it'll go download MSVC and the Windows SDKs from the Microsoft CDNs, and it'll set it all up auto SDK style, and set all your environment variables. It also does this whenever you run a build, which means you don't have to install Visual Studio or MSVC on your build servers. When UET build kicks off, it'll just go and install the SDKs if it needs them. It can also do it for the console SDKs on demand. Obviously, you have to tell it how to install console SDKs because it can't exactly ship that in an open source project, but there's documentation on how you can set up a JSON file and an environment variable to make sure that all your build servers know how to install the console SDKs on demand as well. So, benefits so far, this list is going to get longer, but we can easily build our project or plugin from the command line. We can easily run our automation tests from the command line. We can generate our solution files, and we can install all the required SDKs on build and developer machines automatically. How am I doing for time? Oh God, I'm going super fast. I'll slow down. Do our builds run in parallel yet? Well, it'd be nice to have, for example, Windows and Android building at the same time, but we currently have only one node, in this case, just our local machine. To build in parallel, we need a build server and multiple build machines. So I use GitLab. Now, technically, any build server will do. You don't need to use GitLab in order to use UET, but currently GitLab's the only build server that UET can distribute build jobs on, and that's just because UET has to know how to turn the build graph JSON into the build server specific job description. So for GitLab, that's a YAML file. For Jenkins, it's job DSL and so on and so forth. I do want to add support for Jenkins and TeamCity in the future, and also support for Perforce. Again, you can use UET with Perforce. It's just in the case of where you're distributing builds on a build server, UET has to know how to set up the workspace for each of those builds that are being distributed. And the architecture in UET is reasonably abstract for this as well, so if you don't want to wait for me to do it, you can do it yourself. It's not that complicated. How do you set up GitLab? If you have 5 or less people on your team, the free SaaS offering might work for you, but it gets pretty expensive fast. So I would actually recommend just self-hosting GitLab. It's also open source, free. You can just install it on a box on your machine. All you really need is a Linux box running a Ubuntu or a VM or something like that. I deploy in Kubernetes, but I have 2,000 customers that need to access my source code, so you probably don't really need the same scale that I do for GitLab. What does that get us? All of these builds running in parallel. So you can see this is an example from the EOS plugin. I'm building for 4 engine versions in parallel. We can see all of the downstream jobs building for all of the platforms. All of these are running in parallel. It's true graph-based build, so whenever a build job is never blocking, waiting on something when it should be able to start immediately, as long as you've got the build servers available. All you need to do is register build agents in GitLab, and then all you do is you pass the executor flag to UET build, which tells it, hey, instead of running the build yourself, output the build job file suitable for that build server, which you can then pass into the actual build server. Before we use this, you'll need to set up some shared storage. This is a normal Windows share on some computer, on a network, on your office network. Doesn't matter where it is, as long as all the build agents can access it, and it has enough disk space to store the build artifacts from your builds. For the examples ahead, we're just going to pretend it's called server artifacts. All you have to do is set the environment variables, shared storage Windows path or shared storage Mac path, to how these paths can be accessed on each build server. You can set those environment variables globally on GitLab so that you don't have to pass it into each build. Or if you really want to, you could pass it in on the command line. That's an option as well. How would you use UET with GitLab? So on the top right here, is my pointer going to work? It is. Cool. On the top right, this is just an example of a GitLab build file, and basically it's got the 2 stages: generate and then execute. And so what it's doing is it's going to download UET, And then it's just going to run UET in that special executor mode that I was mentioning, and then we set the execution output file. And then the execution stage just basically takes in that file as an artifact, and GitLab goes and runs all of the build jobs that UET wants it to run. I will note that your build agents should be tagged with build graph Windows and build graph Mac, just so that you can figure out which platform each job is going to be running on. And I also make a note that you'll notice that this is a uet.shim.executable. For build servers, there's a much lighter weight, smaller version of UET that just bootstraps into the right version of UET for your project, rather than downloading the full binary. So what does this get us? It gets us massively parallelized builds via our GitLab build server. We can also retry individual build steps via the GitLab UI if they fail, which is an improvement over before having to rerun the whole build. All right. So what about more complex builds? So we've seen some pretty simple examples. But what if we want to build for multiple stores or distributions? What if we want to build plugins for like marketplace and non-marketplace distributions, which is something that I do? How do we tell it how to run our automation tests or gauntlet tests or commandlet tests on the build server? And how do we specify how to deploy projects and plugins after the build? So to do that, we use a file called buildconfig.json. This is a JSON file, and you can use it to specify exactly how you want the project or plugin to be built. It lets you set up different distributions, so you can have different configurations for when you're building on the main branch versus like a pull request. You can set up like how to build, for example, overnight, like include what you use builds, or to vary how things are built between different stores. You can also specify what tests you want to run on the build server, automation, commandlet, but you can also use custom PowerShell scripts so that you can do whatever kind of test you want. You can also set up deployments. So again, custom PowerShell scripts for if you've got something that isn't covered. For plugins, it supports uploading to Backblaze B2, which is just like a cheaper S3. And then in future, I want to add support for deploying straight to a Steam channel for projects as well. You can also set up custom preparation steps, which run before each build job executes, so you can set up the either modify the state of the working directory however you like. So a simple version of buildconfig.json for a project. We've got this UET version. This is an optional field at the top here, and this is basically the version number of UET. And this makes sure that when a developer or the build server runs UET, it doesn't matter what version they have currently installed globally. If it detects that its version doesn't match what's in the build config JSON file, it'll go download that version so that everybody runs exactly the same version of UET. So there's no more, it works on my machine. And then distributions, it's an array of of each distribution that you want to set up, and you pass it in with this -d flag here. Just to match up with the name. Default isn't anything special. I just, used that as the default name for this example, but you can call it whatever you want. You can set up the subdirectory for the folder. If you're like me and you have a bunch of different example projects in the same repository, this is useful. Otherwise, you can just set it to be a dot for the same directory that the project is currently located in. And then we basically just say how do we want to build the game? So what is the editor target we're building? What's the game targets we're going to build? Win64, Mac, what platforms, configurations. Of note, you can also set server and client here if you're using those variants from like a source version of the engine, and that works too. We can add some automation tests to this. So just underneath the build section, we can add the test section. The name is going to be just the build job name, whatever you want it to appear as on GitLab. You can set the test type. So in this case, this is an automation test example. And then you just set the target name, which is the name of your editor target, and the test prefix of the test you want to run. There's more options to this, such as like configuring retries and like timeouts and so on and so forth. I'll get to where those are covered in a moment. So how do we build and test with a buildconfig.json file setup? We do UET build. We use --test to say, hey, run the tests that are configured as part of this build, and we set the distribution name. And then the build server is pretty much the same, except we're just adding that flag to say, hey, output for output a file for the build server to consume instead of running it yourself. And if you want to enable deployment steps, you just do --deploy. And having these flags means that if you want to have both the builds, both the main branch and like pull requests use pretty much the same configuration, you can use the same configuration and then just set --deploy just on the main branch. All right. Building plugins, you can also build plugins with buildconfig.json. It's broadly the same, there's a few extra options. So for example, you can set the copyright headers, and then as part of the packaging process, UET will go through and fix up all of the copyright headers in all of your files to make sure it meets the marketplace standards for publishing. Particularly of note because the marketplace requires the year, and going and updating every file in your repository just to change the year is kind of a bit redundant. So we can just do this on package instead. And then there's extra things like setting environment variables or cleaning files in the workspace. And you can also set the packaging options because you can distribute a plugin for the marketplace or as a standalone plugin that people can install. And those options just let you control that. You can also use buildconfig.json to build the engine, and you can use it to make a version of the engine that is like the one that Epic ships in the launcher. But you can add console support and dedicated server support, and also set up the mobile provisioning certificates for iOS, so you don't have to go to Keychain and install all of the mobile certs for things to be signed and built. You can also use mobile provisions on project builds as well, and again, it'll install everything to Keychain automatically for you. And there's way more configuration options than that. Too many to list here. But if you add the schema field to the top of your JSON file, then Visual Studio Code will autocomplete everything for you and give you all of the documentation in line so you can see all the options that are available for buildconfig.json. And this is also automatically updated as well. So, or I should say that the schema actually checks for the UET version and then loads the schema specific for the version of UET you're using, and all the deployment process of UET itself automatically updates this schema, so the moment you use a new version, you'll have all the documentation and autocomplete updated as well. So now we can specify different configurations with buildconfig.json distributions. We can configure how tests and deployments run on the build server, and we can validate plugins for marketplace distribution. So that's all nice, but at least in my case, the GitLab UI kind of sucks for complex builds because you've got to kind of awkwardly click through to all of these like subgraphs to see what went wrong, and that kind of is not great for being effective. So I built a better build monitor for GitLab, which looks like this. And the nice thing about this is that it will show you all the progress of all the builds on all the build servers and give you estimates of how long the build will take. It looks at the last, I think, 5 successful builds and gives you the 80th percentile to sort of give you an estimate of the time remaining. It also shows you all of the downstream builds, like all the way down, so that you can see the full status of your build job as it's running. It also will show you the status of all the automation tests as they run. So it will show you how many, what's currently being worked on the current worker, and how many automation tests are left to go, and which ones have passed and which ones have failed. Where can you get it? This is the link. Don't worry, I'm going to put all the links up on the final slide, so you don't have to worry about screen capping it as I go. But some guidance to install I/O is on that page. The setup scripts that are there do require Kubernetes, but you don't actually need Kubernetes to deploy it. It just needs like Redis and Postgres. Again, you could just stick it on the same Ubuntu box that you've got GitLab on. So now we can see what all of our build servers are doing at all times. We can view all of our in-progress build jobs, pipelines, automation tests with time estimates as well. What problems do we still have? So there's always more problems. So with this setup, we can only run one Unreal Engine build per machine at a time due to the global mutex. If you've ever run into another instance of automation tool is running, you will know this issue. We also have to install new Unreal Engine versions on all of our build agents when we need them. So if we upgrade the engine in our studio, we're going to have to go to every single build machine and install Unreal Engine, the new version of Unreal Engine on it, and that's going to be time consuming. Even if you pre-download Unreal Engine, copying it or to each machine is kind of slow because NTFS doesn't do well with 100,000 files. And if you're like me and you're doing plugin development and you have to target multiple engine versions, that's a lot of disk space used, right? Because you're going to be talking 100 plus gig for each engine version. Is there a better way to package and install Unreal Engine? What do we want? We want a single file that just contains the whole Unreal Engine install. And we don't want to have to extract it, we just want to mount it in place. It turns out we can do this with VHD disk images on Windows and sparse image disk images on macOS. So I implemented that in a tool called UEFS, which is actually now part of UET. So to make ourselves an Unreal Engine package that has the engine inside it, usually for sort of basic setup, you're going to go to one machine, get Unreal Engine installed on it, and then you're going to ask UEFS to make a packaged version of that Unreal Engine install and stick it inside a VHD file. And then we can mount that package wherever we want with UEFS using the mount command. So in this case, we would get Unreal Engine 5.3 at that directory path. And we can mount the same package multiple times. So in this case, we get 3 fresh copies of, I should say Unreal Engine 5.3, but because the automation tool mutex is per engine installation, it means we can run a build job in each of these folders in parallel on the same build machine, and we no longer have to worry about the automation mutex preventing us from doing as much work as possible on each machine. So how do we get these packages around? Well, if we have lots of build servers, we still need a way of synchronizing all these VHDs to every machine. We could put the VHD on a network share, but like the underlying disk reads would be kind of slow, and then we have to kind of hard code a path to the network share and all that build jobs, and this solution doesn't scale very well. So instead, UEFS uses a container registry. This is the same kind of container registry that, for example, Docker and Kubernetes use. We don't actually put the VHD file in there. We kind of just use the container registry for versioning. We put the VHD file on a network share, but we use the container registry as like a tag that we can update to different VHD files as we're updating the engine. And on Windows, we actually project a folder with virtual VHDs in it. And this allows us to instantly mount Unreal Engine over the network without pulling it first, without downloading or copying Unreal Engine onto each machine. And then as the build process or as the editor accesses files in that mounted folder, UEFS will pull each 128 kilobyte block over the network, cache it on the local machine, and then keep it there forever. And this saves you quite a lot of disk space. So on a 100 gig Unreal Engine install, if you launch the editor like this, you'll only be using about 3 gig of space by the time the editor comes up. And if you launch the editor again, because everything's cached, it will launch in about 10 seconds. So you basically have no performance loss after the first time run. And even the first time run's not too bad. It's about a minute and a half on like a 1 gig normal LAN connection. So it's pretty decent. How does this work? Like before, we build our VHD package off the directory. We've got our container registry. Of note, GitLab comes with a container registry that you can conveniently use for this. And we've got our network share, which again, you probably already have set up because you've set up a network share for the build artifacts. I'm going to get some water. Cool. So after we build it, we'll get a VHD and a digest file, which is just a hash of the VHD. And we copy these onto a network share in your studio somewhere or in your office. Then we tell the container registry, or we push that to the container registry. Again, we're not pushing the actual VHD there. We're actually just pushing this little ref string, which is just the path to the VHD for all the build servers to use. And we can set our tag here, registry, gitlab.com or repo, whatever. And then when we build, when we use that little engine flag, instead of passing in an engine version or a path, we do UEFS, and then the container tag. And that's pretty much it. It'll now go and look up the container, or go look up the package from the container registry, figure out that the ref points at that network share, and then use that instant mount sort of technology I talked about before, to just instantly mount Unreal Engine over the network without having to pull anything, at least on Windows. So how to install it? How to install UEFS, sorry. On Windows, you install the WinFSP file system driver. That's what allows UET to, or UEFS to do that virtual file system that backs those VHDs. And then from an administrator or root prompt on macOS, you install the UEFS daemon, which handles all the mounting requests. So if WinFSP is not installed, or if you're running things on macOS, UEFS will still pull the entire package to disk. Now, even in that case, you still get the versioning benefits, and you still get the benefit of not having to go to each build machine and manually install Unreal Engine. So even though you don't get the disk benefit, the disk usage benefit on macOS, it still vastly simplifies updating Unreal Engine across all of your build servers. Oh, and as I mentioned before, on Windows, the VFS will reduce it to about 3 gig needed to run the editor. macOS is pretty much the same. We build a package, this time it's a sparse image, again, path to where Unreal Engine is installed. We copy the sparse image and the digest file to the network share, and then we use UEFS push to push that reference up to the container registry. You will notice that the tag is exactly the same, and this is because UEFS will actually go and pull either the VHD or the sparse image, depending on what platform it's running on. So you can use exactly the same container tag for the build, and regardless of where your build jobs run, it'll know how to get the engine on both Mac and Windows. Cool. Wrapping up. So I apologize if I talked a little fast. So our benefits now from using all of this stuff: we can easily build projects, plugins, and the engine itself. We can easily run our automation tests from the command line, generate Visual Studio projects and solutions, install all the required SDKs. We get parallel builds through GitLab. We can set up complicated or more complex deployments with build config.json. We can validate our plugins for marketplace distribution, easily see what all of our build servers are doing, view all of our in-progress build jobs, version Unreal Engine for Windows and macOS via a container registry, run multiple Unreal Engine builds at the same time on the same machine, and then also mount Unreal Engine instantly over the network on Windows with no performance hit and greatly reduced disk space usage. So, how do you install it? First of all, you go to that website and you click the download button. And then at the command line, you'll run UET upgrade. And that will install UET globally, and then you can just use any of the commands I've shown you today, just from the command line anywhere. That's it. So here's all the links. Yeah, and I think with that, I will take questions. Any questions? I'll let everybody take photos first.
Just a quick question. Does this work on older versions like, say, 4.25?
It'll work on 5.0 and above.
Okay.
Sorry. Yeah, so I did a rewrite. So before UET, I had a version of this sort of stuff called the Unreal Engine scripts. It was all written in PowerShell. It got to a point where the PowerShell was kind of getting a bit unwieldy. And so right at the same time when I was changing over from the Unreal Engine scripts to UET was also at the point where that 4.27 dropped off the support range of like 5.3 had just, or 5.2 had just come out. So 4.27 dropped off, and I'm like, I'm not going to go and necessarily put 4.27 into UET. If you do need to do 4.27, you can get a lot of these features out of the Unreal Engine scripts, but they are, unmaintained. UET is the hot stuff. So, yeah. Any other questions?
You said earlier that the Jenkins support was incoming. Was there specific reasons as to what would it
I just haven't got
for?
around to doing it yet.
Okay.
Yeah.
Because it seems like it should work, though.
Yeah, so if you want to, if you just have one build machine, right, and you're just using Jenkins to do automation, you can totally just use UET build from Jenkins. You're just not going to get that, I have multiple build machines, I want to distribute the builds across multiple build machines. It's that sort of, it's the, go through all the slides. It is, this part where all of the builds are split into individual jobs. So
it's kind of sort of like, interested in just a solo sort of build machine.
yeah, if you just got one build machine, you don't need to build things in parallel. You can just use
Okay.
UAT
Excellent.
build. Yeah.
Cool, thanks.
Oh, that was too far. I was trying to get back to the end. No. There you go. Any other questions while I do this? No? All right, I'm just going to put the link. I was just putting the links back up. Cool. Well, if there's no other questions, yeah, thanks for having me.